So we've developed a new product for the range, Cynosa, specifically to enable plants to take up silicon in the only form they can. The reasoning behind the development was really to look at helping cereals develop better, but I think silicon has, as we've seen, other applications in a whole range of crops. But I was particularly interested in looking at rice and cereals because it's well known that rice is a silicon accumulator, can take up to 10% of its weight in silicon, but it needs access to it. So the clever chemistry in Cynosa allows the formation of orthosilicic acid, small polymers of charged particles that is very easily taken up by the plant. As we know, silicon is ubiquitous on the planet, but it can't be taken up in its inert form. The plant can only access it in the form of orthosilicic acid. So we've done a lot of work to develop the product.
Yeah, I mean, you're right. Different plants accumulate and depend on silicon at different levels. So as you mentioned, rice is a very active accumulator. It needs a lot of silicon to, number one, make it structurally sound, but also to work within its metabolic processes. And you find that different plants have different requirements for silicon. And as you quite rightly said, in many soils, silicon is not available to the plant. And silicon really acts in plants in two ways. Number one, there's the structural aspect to it, and that basically involves laying down silicon dioxide in the plant tissues, and that can be structurally very important for many crops, including rice and other cereals.
Yeah, obviously the lodging effect, particularly in rice, if the plant is laid down because of weather conditions,
yes,
it's not going to return.
And plant breeders have developed varieties of cereal that are short, dwarf varieties, and part of the rationale there is to prevent lodging or blowing over in the wind. Silicon can play an active part in that resistance against wind damage as well. But the other important aspect of silicon is its action as a biostimulant. Silicon itself can actually stimulate a number of genes in the plant and influence those metabolic processes. And that in particular involves things like resistance to drought, other abiotic stresses, and general growth and development.
Also, there's some evidence to suggest that with the laying down of silicon on surfaces of the leaves and stem, that it's harder for predators to attack the plant.
Yes.
And also it's more difficult for some diseases to gain a foothold in the plant tissue.
Yes, certainly it's been shown on a number of occasions that insects that are feeding on leaves are less able to attack the plant if there are higher levels of silicon in those tissues. They're basically blocking the insect mouth parts. And the same holds for infection. Early infection by many fungi involves the fungus growing through the outer epidermal tissues into the inner parts of the plant. If you've got a layer of silicon, it can prevent that.